Hello, Jeremy here. For this episode, we are going to go into character states. What are character states? Character states are, is your guy walking, is he standing, is he still, is he jumping, is he running, is he attacking, are all of the states your character can be in, and the animation can be different. So we'll go and show the basic states that the sprite sheet I'm using has, and I will be doing that using my GIMP, my graphics editor. Okay, so here we go. Here's the states. I've showed this before, but now we can think of, there's going to be two states. There's going to be idle and walking. But also there will be a direction that the character is facing. So this is idle and facing down. This is idle and facing left. This is idle and facing up. And this is idle facing right. This is idle, this is walking down. This is walking left, walking up, and walking right. So that's how I'm going to break things down. I'm going to have a way to be idle, and a way to be walking, and a way to have a direction that we're facing. So those are the states I'm going to provide, and then we will determine which animation we're going to be playing by what state link is in. Okay, so let's go ahead and pull up the editor. All right. We have the editor going. You can go ahead and find the character. Search for character. That was a bad search choice. Let's use capital char. Better. Okay. So when we make a character, we're going to need to have a direction. So we need direction. So what's the best way to do this? Well, let's just do it the easiest way first. So there comes a time where we need to update this, we can update it. The easiest way to do this is just we're going to define constants at the global level. So we'll be doing idle equals 0 and running equals 1. So these are, walking, if it's walking. We probably want to find sprites, like a sprite sheet that has other states. However, this is basic, so let's just go with this. So this is the, I don't know, motion states? Not sure. Motion states. Then we're going to have the direction states. And these are facing down equals 0. Facing left equals 1. Facing up equals 2. Facing right equals 3. Okay, these are how we're going to determine our states. So we're going to have to maintain two variables that keep track of the state. So self.motion equals motion. Let's just say motion. Dot direction equals direction. And I can provide those up here. Motion and direction. So when we create the character, we need to give them which way they're facing and which they're idle or running, while we're walking. They'll probably be idle when they first get created. So we can default this if we want to. The animation is going to be a little more tricky. We could default the animation as well. I'm not going to do that right now. Let's just do this for the time being. Okay, we'll have that. That sets up the states when we build the character. Now we gotta know when we update the character what's going on. I'm going to remove the mouse motion because we no longer want to move the mouse to do things. We want to use the keyboard to do things. So we're going to get rid of this. What we're going to do is event.type equals, I think this is HighGain.key down. Has. We're going to make this an else if. The reason why we do if, else if, is one of the main reasons why I do it is that it makes it more, it makes it easier to follow. The idea is if this is true and we execute this block, you don't have to care about all the other blocks in this statement because they can't execute. It's impossible for them to execute. So if you had another else if here, else if something, and then you do something here, and you have else something else. You don't need to concern yourself. If it matches here, you only need to look at this block. You don't have to worry about all the other three. If they were if statements, each of them. There's something else. They were if statements like this. You have to go through each of them because they could evaluate true here. So that's what the else if grants you, is it grants you this ability to not care about the rest of the code. You look at one branch, that's all you need to look at. That's why I prefer to use an else if all possible. It may not be possible in what you're coding, but that's okay. Use it whenever possible, and it should help, and it should ease your coding. Okay. So if the key down, we have a key down, and if event.key equals HighGain.key, we're going to use ASWD keys. That's a standard thing. So let's do this. Let's S. I'm actually going to try to use both. Is there a down? There probably is a virtual down. So I'm going to go into my web browser and internet search for HighGain and down arrow. Okay, so it's K up, K down, K left, K right. Easy. I could have probably guessed that. So I'm going to say in. So we want HighGain.K down. So if the key is either S or the down arrow, so we'll use both the keypad or ASWD. We're going to say this is self.direction equals facing down. Olive. Same idea. Back, I say back. So this is going to be the pattern. And I'm going to say that's 2. And then copy. And Well, the question is, do we want to do it every time it's down? Whatever, who cares? Okay, so down, left is going to be A, C, left, and this is going to be left. Up, this will be right. Okay, so now you see that this is W, up, right. Good. Okay, so that should be it for key down and making the directions update. So what I'm going to do is just try this out. And Lindy trolley. We need to do one more. We need to do another thing, but I need to. Okay, so what we need to have happen is the character needs to be able to know the animations for that for itself and means particular things. So we need the full collection of animations to play through. So to do that, we're going to need the animation for the different states given to it. So what I would say is we're going to use a map. So this is an animation map. Our state, let's just call it state to animation. There we go. That's better. So we're going to record this as state to animation. State to animation. Okay, so let me just show you how this is going to work. Is we're going to create, like down here, this is almost correct. So I'm going to say state to animation. This is going to be a dictionary object or a map object. And what we can use here are the states that we want. So we want idle. We want the idle state and down, facing down. And this is going to link to an animation 0.00. The link grid is going to be 0, and there are 3 animations in that grid. So we're going to do it this way, and we want, I don't know, 2 frames. I'm guessing. I have no idea if that's correct or not. We'll play them out. We'll see if that looks good. If 2 seconds is good timing. So here we go. I'm going to then do idle. Let's just pop up. I'm looking at this on my monitor. Maybe that's making it harder for you to understand. So we're saying that this animation, this row, which is row 0 and 3 elements in row 0. So we're saying I want these cells for the animation for the idle facing down animation. And then I'm going to want these guys for the idle facing left animation. Okay. Left animation. I'm going to actually copy this because it's basically the same thing. I'm just updating it. There are 8, 2, 3, 4, 5, 6, 7, 8. Okay, so idle facing left. This is going to be 1, 2, 3, 4, 5, 6, 7. Okay, the facing left animation has 3 of them. Just show you. 1, 2, 3, then 1, then 1, 2, 3. Okay, then 1, then 1, 2, 3. Okay, so let's go fix these. This is facing up, and this is facing right. Okay, so those are that. I am unhappy with that. This, that'll give me some more. So this should be walking. 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 Okay, so all of the walking animations have the full 10 frames, so we don't need to worry about the slices. This will just be 4. This will be 5. This will be 6, and this will be 7. All right, so that's the different animations that we've mapped to. All right. So when we look up in this list using this tuple, okay, I'm going to pop up the repo to show you how this operates. So Python. I'm going to copy over the definitions that I have. So we can just use it. Okay. The idea is we're going to create a mapping state to string, sure. And I'm going to say idle facing down. Idle link is idle and facing down. Idle facing up. Link is idle and facing up. Walking facing right. Link is walking and facing right. Okay, so that's how we define it. We can type it out. And that's the mapping with no printing. However, let's go ahead and do a lookup to state to string. And then you're going to look up idle facing up. So in this case, we're using a tuple. This idle facing up is a tuple. Idle facing up. So it's a tuple of 0, 2, and that's what's stored here. And you can see 0, 2, link is idle and facing up. So we're using numbers to represent states in a particular variable. It's fairly simple way of doing things. So when we use this tuple, which is a immutable data structure, we can use it as a key in a dictionary lookup. So we can look this up. And this is how we are going to combine our idle, our motion, and direction states when we look up the animation. Just like we can look up the string, we can look up the animation. You'll find that this dictionary is incomplete because I do not have walking and kissing up in here. I am missing quite a few states actually. And you'll see key error 1, 2 because 1, 2 is not a key in this dictionary. So it's telling me there's no key error. Okay, so this is the basis of what we're doing to look up the animation we're going to be using. So let's go ahead and do that. Okay, so if there has been an update, we want to update the animation. Yes. Sure, I guess. We want to update our image. And say we've updated in general. So I want to do a little different. Updated needs to be set. And we only want to change states of updated to set. So what we need to do is we need to do self.image equals. We need to update the animation, and we need to update the image from that animation. Yeah, we need to have the animation in here. Self.animation equals self.state to animation. To look up self.motion, comma self.direction. So that's going to be the animation that we need. And this is going to update here. Then the image needs to be changed, I believe. Do we need to change the image? No, we can do it there. That can happen automatically if it's a tick event. So it'll key down, it'll change the animation in the next cycle, or refresh it with a tick. So we should just be able to do self.updated equals true. So this should happen in any case where the direction has changed. Now, we could get the old direction that the character was doing, or we can get I could just make this a function, part of a function. Could make a property, which would probably be the best. Okay, I'll make this into a property. So we'll go. This needs to be motion, direction. I'll probably need to do this for both of them. So this is what I want to happen. But I want to make it happen everywhere without being like duplicating lots of code. Def direction self return self dot direction. This into a property. Now we can do direction setter. Yeah, this syntax really makes no sense to me, but this is the syntax to get it done. Copy. So what's happening here is we're going to set the direction with the value. Then we're going to update the animation, and then we're going to say updated is true. So whenever we set the direction here, it's actually going to call this property setter, the setter property here, and do these things. So now we don't need this, and we can keep the rest of the code the way it is. And that should update it. So we're always working. Okay. So now when we instantiate our character, I'll keep those animations. Oh, animation down. Let's get rid of those animations. That way we're not cluttering up our screen anymore. Character 0, but now we need him to be idle, facing down, and the state to animation that would be passed in. Okay, well, if I did everything right, which I have a history of not doing, we will see it work on the keyboard with great awesomeness. Yes. Okay. Okay. I missed something, of course. When we construct the sprite, we are not using the proper image. So let's go fix that. I knew I had to do something wrong. It was inevitable. But just once, I would like to get something right. Wouldn't that be amazing? Yeah, I think it'd be amazing. Okay. So that's happening in line 300. Okay. Line 300. Happening here. Animation link grid. So I'm giving it the sprite, a list of sprites. Okay, so when we construct the animation, it should be a list of sprites that we're dealing with. Animation sprites of 0. Object has no attribute image. Yes, that is true. That is way true. That seems fine. What's possible is the map not correct. Linked grid is not correct. Linked grid is not returning the right things. That's possible. It's possible that these slices don't work how I think they work. Maybe. This might not be possible to do like this. So I'm going to get rid of this for now because I think this might be the bug. Comment. I need to comment out the old ones and put in copies. That way I'll remind myself to fix it later. This slicing may be causing problems. Okay, try again. Oh, blink in and out of existence. Nice. Okay, so that is working because I need to, as you saw, it looked like I was blinking in and out of existence is because it was playing frames that had nothing in it. So it wasn't displaying anything. So that's why it looked like it was blinking in and out of existence. Now, I do not know why the slices were failing. However, we can just fix the slices. So I should be able to get that array. Okay, get the array. And I should be able to slice afterwards. I think I should be able to go :3. Let's see. Yeah. So that blinky animation is really scary. Okay. Well, that works. Ah, that is awkward. Okay, this is :3. I think to get the slicing to be supported inside the brackets where it should be is I need to add that to the get item. And I'm not sure how to do that at the moment, so I won't do it at the moment. I'll do it later, so I won't waste more time than necessary. Okay, I'm gonna make this less blinky, less blinky, less blinky. Okay. Okay, well, there's that. So we may need to make another set of animations. The idle animation seems pretty crazy. Maybe we need to make it even more in between. Let's try it out. It's probably okay-ish. Let's hit right. Okay, so now this is where the next error happens. So I hit right on the keyboard and I get this. What in the heck is going on here? It just repeats the same thing over and over again, and then it says maximum recursion depth exceeded. Okay, so this is a issue with what I did in the code. I'm pretty sure I know exactly what the problem is, but the reason why this usually happens is known to something called recursion. So I will show you recursion in its very basicness. So that's recursion. So what you do is you define A and you call A inside A. And that's that. So A is defined by calling A. Typically, you will see this used. So it's a pretty important computer science concept, and it is a little more advanced, but I think you can get the handle on it. In this case, when you call A, what it does is it calls A, and then it goes to A, calls A, calls A, calls A, and it does this in a loop. The reason why it's called recursive is you define a recursive function in terms of itself. So typically what you do is you use recursive functions when you want to do the same thing on many levels. If you don't have loops, you can use recursion to do loops. For example, if you want to traverse directories and rename all files that say link to Zelda, you can use recursion to do that. You can use many different things. Recursion has lots of mathematical things. There's Fibonacci sequence which uses recursion. Lists can be defined in forms of recursion. You can do lots of things with recursion. However, what we're seeing here is maximum recursion depth exceeded. The problem here is that when you make a function call, there are things that are being saved into memory on an area of memory known as the stack. And you can think of the stack as a place that you can place variables and data that operates kind of like a stack of plates. The newest piece of data goes on top of the stack, and you can only access the top of the stack when you want to take things out of the stack. So when you make function calls, you pass, so let's say x comma y, return x plus y. When I define this function, I do a function call. What's happening is in the really base, low-level code, it's pushing 1 into the stack, so you have 1. Then it pushes 2, and you have a 2, and then it pushes the return address. So where the code needs to continue, where the code was called from, return address plus the instruction length. So it's actually on the next line of code in the instructions that are given to it. And so this data is stored onto the stack. So what's happening here is it's pushing 1 into and the return address into the stack. Then it calls in this recursive, so that's what this. In this recursive function I define, it's just pushing the return address back into the stack and calling itself, pushing the return address in the stack, calling itself. So it's filling up all the memory with the return address. And since it does that to infinity, it eventually has to kill itself, and Python catches that. So it doesn't fill up all the memory that you have on your computer system. So this is what that is. So we have recursion going on. And we have recursion going on because when I define the property here, I did not change this to use underscore. So what's happening is when you have it like this, it was taking this, calling the direction setter, it's doing a recursive loop right here. This was the same kind of thing you saw when I showed you earlier. It's just doing this in a loop. Call self, call self, call self, call self, in a loop. Now we do it here, it's a different, there's no direction isn't a setter, so now it's dealing with this variable that we have defined here, and we update that variable value. That's why I gave these underscores. Okay, so that should fix that problem. Okay, hit left. Hey, down, left. Oh, sorry, that was right. Left, up. Yay! It's a bit laggy, but as you can see, we are able to change the state. Now, we just have one last thing to do. When we have a key down event that is any one of these guys, we want to change the state to walking. Self.walking, self.motion equals walking. That's fine. And then if we get a key up event, if event.type equals hiding.key up. Good. Almost great. Then we want to do self.motion equals idle. And do self.updated equals true. Okay. And this should be else if. So now we're holding down the arrow keys or ASDW keys. You should see Link doing the walking animation, and then when we let go, it should go to the idle animation. Do this. No, don't want to do it. I'm holding it. Okay. Self.motion equals walking. Oh. Yeah, no wonder Guy doesn't want to do it. And it's underscore motion too. Okay. There we go. There we go. Stop. Stop. Key up. Stop. Okay, it's not stopping. Curse you, Link. Because I'm not updating the animation, that's why. Okay. Maybe we need to do the same thing for motion. No, we need to do this. That might be an issue. Well, let's do this now. Let's actually make the same thing for motion. So we can go motion, 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 motion. It's the motion. Self.motion equals value. Don't do anything with direction. Update the animation. Great. Thank you. Go ahead and do that. Sweet, sweet, sweet. All right. So that is Link being updated with states and having all the animations being played through in this idle animation. We're going to update this probably a bit more in a later episode because this has gone on for quite a bit. I want to play this idle animation after a certain period of time. So that will be the update. We'll have an idle, we'll have like a stop, like a still, or a still state. And then we'll have an idle state, then we'll have a walking state. And the still state will just show the first frame of whatever direction it's facing. So, or we can maybe stop the animation. I'm not quite sure how I want to do it. But that is it for this episode. I will, in the next episode, do that update to the idle state. And what did I have? I had something written down. I want to do layers next. So have a good day and see you next episode.